Okay, so let's go ahead and check out reference angles. Reference angle is an acute angle that is formed by the terminal side and x-axis. So this x-axis is super important here. And then remember what acute means. Acute means that your angle, this thing that's an angle, that's theta, is between 0 and 90 degrees. So if we think about our axes here, right? And yesterday we were talking about angles. This was the initial side on the positive x-axis, and then your terminal side was how much your angle was opening. So this is the terminal side. And then your x-axis. What I like to think about a reference angle is it's kind of like the distance, the degree distance, if you will, because it's always in degrees, from your terminal side to that x-axis. So if we have an angle that's in this first quadrant, like right here, this is going to be your reference angle. So it is whatever the angle is. So we can put on your chart here, right, as is. And then if you have an angle that's in your second quadrant, okay, so it's the distance from this terminal side. So think about this being my angle, okay, the terminal side, to the x-axis. So how much farther do I have to go until I get to that 180 degree mark? So the way that we can find that out is by taking 180 minus whatever your angle is. Now remember that this is 180, but it's also pi. So if we're dealing with radians, you're just going to do pi minus your angle. And then if we have an angle that's in quadrant 3, so we've got our initial side, our terminal side. Again, we're going how far away are we from our x-axis? So that's going to be this space here. So really it's how far past my x-axis did I go? And the way that we're going to find that is by doing our angle minus 180, or our angle minus pi. And then finally, if we have an angle that's in that fourth quadrant, starting here, going all the way around to there, it's how much farther do I have to go? How many more degrees do I have to go until I hit that x-axis? So the way that we're going to find that is by taking 360 for all the way around the circle minus our angle, or if we're doing radians, 2 pi minus the angle. Okay, so if you look here at example A, theta equals 120 degrees. So theta, that's just your angle saying we have 120 degrees. So I'm going to go ahead and sketch that to see where I have, what quadrant that's in, and that is in quadrant 2. So if I go based off of the chart that we just wrote down, in quadrant 2, that's telling me, because I'm in degrees, 180 minus my angle. Well, that should make sense because it's how many more degrees do I need until I get to that positive x-axis, or not positive, sorry, but just the x-axis. So I would take 180 minus 120 and get 60 degrees. So my reference angle is 60 degrees. Your reference angle will always be a positive number between 0 and 90. And that's just telling me how much farther I have to go. So if we look at example B, my angle is 290 degrees. So again, let's go ahead and sketch that angle, 290 degrees. So 290 degrees is going to start positive x-axis. It's going to go past that 270 mark. So it's this whole entire angle here. So what I'm looking for is how much farther do I have? How many more degrees do I have to move until I get to that positive x-axis, or x-axis? I keep saying positive, so sorry. So if we look on our chart, well, since my angle is in the fourth quadrant, that's telling me that I'm going to have to do 360 minus my angle. So if I did 360 minus 290, that's telling me I have 70 more degrees until I would hit that x-axis. And there's that answer, positive between 0 and 90. Moving on to example C, theta equals 200 degrees. Go ahead and sketch that. So 200 degrees is going to be just past the 180. So it's how much past the 180 is what we're trying to figure out. How far away from the x-axis am I? How much did I surpass the 180? Well, going back to our chart, third quadrant here is telling me we're going to have to do our angle minus 180. So my angle is 200 minus 180 means I went 20 degrees past that x-axis. Last degree example here, theta equals 60 degrees. Go ahead and sketch that. 60 degrees is going to be right here in quadrant 1. And if you look at your chart, that is as is because I am 60 degrees away from that x-axis. So my reference angle is my angle itself at 60 degrees. Okay, so let's go ahead and look at the radian measures now. So my angle is 5 pi over 3. So we have to really understand how to count these radians around the circle. So if we know that this is 0 and this is pi, well, pi, since we're talking about a denominator of 3, pi is really going to be 3 pi over 3, and 2 pi is really going to be 6 pi over 3. So now we have kind of a better gauge. So since I need 5 pi over 3, halfway around my circle from here all the way to this side, that's only 3. Between 3 and 6, this would be 4.5 pi's over 3, which means 5 is going to end up in this quadrant here. So when we think about our angle, this is our angle going all the way around. That represents 5 pi over 3. It's in that fourth quadrant. That's what's most important that we can recognize. So since it's in that fourth quadrant, we're going to go ahead and take all the way around the circle at 360 degrees minus 5 pi over 3. So I'm going to take 6 pi over 3, and I'm going to subtract 5 pi over 3. I'm going to see that my reference angle, how far do I have to go until I get to that x-axis? I have to move pi over 3 more, okay, or that's 60 degrees. Looking at example F, my theta equals 7 pi over 4. So now we want to sketch that. Well, here's 0, this is pi, but now we're not talking about just pi, we're talking about 4 pi over 4. So we're trying to get that unit of measure, that count, that halfway around my circle is 4 pi over 4. And then the other half, this would be 8 pi over 4. That's going to be my 2 pi representing fully around the circle. So here, if I'm trying to think about where my angle is, here's my initial side, and I'm going to go 4. This would be 6 pi over 4. Well, I want 7 pi over 4, so it has to be between 6 and 8, so I'm going to go just a little bit more, and my angle is going to be, again, in that fourth quadrant. So again, I'm going to take that 2 pi, my 8 pi over 4, and I'm going to subtract my angle of 7 pi over 4. And I'm going to see that my reference angle is pi over 4. Okay, so example G. Theta equals 5 pi over 6. If we wanted to sketch that, well, halfway around my circle, that 180 is pi, except we're not talking about pi right now. We're talking about 6 pi over 6. It's the same thing, but we want to get that common denominator so I can see where my angle is. So starting here at 0, if this is 6 and I want only to go 5 pi over 6, well, this halfway to 6 would be 3 pi over 6. That means it must be in here somewhere. So it's in that quadrant 2. Well, quadrant 2 is telling me that I have to do pi minus my angle. So here's my pi, my 6 pi over 6, minus my angle of 5 pi over 6. And when we do that, we end up with pi over 6. And our last example here at H, theta equals 19 pi over 6. Okay, so 19 pi over 6. That's a lot of times around the circle, or more than one at least. So if this is 0, we have our marker of pi. Since my denominator is 6, that's going to represent 6 pi over 6. So I need to figure out where the heck 19 pi over 6 is in my quadrants. So starting here at 0, go around, there's 6, go around, this would be 12 pi over 6. Well, it's more than 12, so that means I have to go around yet again. So now when I get here, another halfway around the circle, that's going to bump me up another pi. So I'm going to be at 18 pi over 6. Well, it's still more than 18, not much more. So that's telling me that my angle is a little bit more. It's going to end up being in this third quadrant right here. So how are we going to figure that one out? Well, this is 18 pi over 6, and if we go back to our chart that is telling us that we're going to have to do our angle minus pi. Well, we can't exactly do our angle minus pi because we went around the circle one more time. So this should be minus. So what we have to do is we have to do our angle of 19 pi over 6 minus 18 pi over 6. And we're doing minus 18 pi over 6 because that's representing that we went around the circle another full time. And then we're getting that our reference angle is pi over 6. Now, maybe you've picked up on the fact that every single time you use radians, your reference angle is just pi over the denominator. I don't ever have to see this work. You can remember that it's pi over the denominator. Yeah. And we're done.